I want to thank our sponsors tonight, Northwestern Utility and Idaho Power Company. Kurt Nichols is here from Idaho Power. Thanks for being here, Kurt. Want to thank the Integrated Design Lab, obviously, the Bozeman Lab and the U of I Lab right here. And we hope there's a lot of folks out there tonight watching via the computer video streaming, because we're going to have a good show for you. Glad for all of you to turn out here. I'm Ken Baker with Better Bricks Education and Training. Again, pleased to have everyone here, and really pleased. This is our final session of the year, and really pleased with our presenter and our presentation tonight, because we scored Dave Hewitt, who is the director of the New Buildings Institute out of Vancouver, Washington. And Dave is a really good friend of Idaho. He used to come over quite a bit, but the last couple of years he hasn't been here, so we got him back to talk about going beyond to getting to 50. We had Mark Frankel talk about getting to 50 and NBI's New Building Institute study on that here just a year ago, within the last year. Dave's going to take us beyond and get into some of the economics of high performance buildings and the information and studies that they've been looking at NBI. Right before I put Dave up here, if you have any questions and you're online and you want to talk to us, email Brad Aker, that's Backer, B-A-C-K-E-R, at uidaho.edu. So email Brad if you have any questions, and we'll get those questions up here. And with that, I want to bring Dave Hewitt, Director of New Buildings Institute, up here to talk to us. Thanks, Dave, for being here.
All right, thank you. So some of you are quite familiar with New Buildings Institute, and some of you are not. So I'm going to start with just an introduction in terms of who we are and a little update into what we're involved in. And then I have a presentation that sort of links together a series of things of informational pieces and work we've been doing. And I'm happy to sort of jump around a little bit or handle questions as I go through this. And frankly, those of you that are in the field, I should just say that there's new stuff coming across our desk every week, and some of the newest stuff hasn't made it into any sort of presentation yet. Like, I'm leaving tonight, going down to San Francisco. We picked up the contract to provide a little bit more leadership to the California Big Bold initiatives for commercial new construction, where they're trying to do the 2030 challenge and run it through the California utilities. And so that's a new project that we're starting on tomorrow. We've got some major proposals to do some advanced daylighting work and other types of advanced design work that are just coming in. So there's a number of things that are happening that I think people may have questions about that. So I'll take sort of more general questions too as we go through this. But just basically on NBI, we're a national nonprofit. We've been around for 10 years. We're just finishing up our 10th year right now. We're in Washington State. We're really focused on commercial building energy efficiency, and especially new commercial building energy efficiency. I've been there for 3 years now. To give you an idea of sort of what's happening in the organization, when I started, we were at 4 people. Now we're at 14. So we've seen a lot of growth, and I think especially right now as we're seeing a lot of job owning over the last year to 18 months becoming actual programs and actual dollars moving towards a different sort of energy efficiency and climate agenda. The scale of things is increasing pretty rapidly. So a few things that we work on, we're sort of, the nickel description of us is that we're a think tank on commercial building energy efficiency. And we tend to work on 3.5 different areas. And those 3 areas are design guidance, emerging technology, and public policy related to those things. And then the half area is measured performance, because as we've gotten into this commercial building world, we've really focused on trying to get actual measured performance on buildings, because we've seen that what we design buildings to do and what they actually do can be quite a bit different from each other. And if we're trying to squeeze towards 50% savings, 75% savings, net zero, it's not all design. A lot of these things are tenant-based kinds of things. A lot of these things are operational in nature. A lot of these things are feedback systems in buildings. And you can't just squeeze design. You can't just squeeze code. You can't just squeeze those things and get all the way home. So, but briefly, some of the things we're dealing with here. Getting to 50 is our code word for trying to get to buildings. We're trying to get to 0, but getting to 50 is like a realistic place you can kind of get to now. So we have getting to 50, and we've just submitted a major proposal on design guidance, which we hope to hear about next month. We are in the midst of redoing our advanced lighting guidelines. That's one of our most widely distributed products. We have about 2,500 people a year download that complete volume off our website. It's going to be an interactive website going forward. Everything's going to be on the web. It'll be continuously updated, and we'll be able to add features to it that will help the lighting design community. So that's an exciting project. We're going to launch that at Light Fair in May. So that new product will roll out then. Core performance, a number of people might be familiar with that because I know there's been a fair amount of training on core performance. That's what our more, I would say it's our basic program. We call it core because it is sort of basic. It's how you can get commercial buildings roughly 25, 30% better than typical codes at this point in time through prescriptive upgrades. Not a lot of stuff in there for the design community. It's better windows, better mechanical, more insulation, it's those sorts of things. And while we call it core, in some ways it pushes the limits of current technology without moving into some different kinds of system approaches. Advanced rooftop units is an area we do a fair amount of work in. We've worked in direct, indirect, evaporatively cooled, combination DX units. We've worked in fault detection and diagnostics built into unitary HVAC, so we've got a lot of work on unitary. With Cascadia Green Building Council, we're working on zero energy projects as part of their Living Building Challenge. We deal with the curriculum and looking at design tools for them. We're the market connecting contractors for Lighting California Futures, which is a collection of advanced technology. Some of it's LED, some of it's controls based, some of it's just new design, but we've got a variety of projects going on there. And we have a pending, I shouldn't say pending, the announcements are supposedly due tomorrow, but we're in the running for a major research project with the California Energy Commission that again has a variety of features. It's got rooftop units, it's got daylighting, it's got measured performance and understanding how buildings are actually doing. On the codes and policy, a lot of what we're doing right now with core performance is trying to move it into national codes. And there's a number of projects across the country. Certainly here, the Northwest Energy Efficiency Alliance is working to try and do better codes regionally. But there's similar groups in other areas of the country, Southwest Energy Efficiency Partnership, Northeast Energy Efficiency Partnerships. There's national groups such as Environment America, which used to be the PERG Energy Foundation group that we're working with to try and do building codes across the country. A new initiative that is just missing you guys so far is the 3 Western states are getting together to say, is there something that the 3 states can combine on, the 3 West Coast states, I should say, to advance the pathway to zero net energy buildings more rapidly. We've had one meeting on that with various representatives from state government trying to figure out what to do there. I think I mentioned I'm starting a contract with the California PUC tomorrow to work with their Big Bold initiative. We work with the federal tax incentives, which have now been extended. Before, the federal tax incentives for whole buildings were in place for 2 years, then a 1-year addition. I basically ignored them because it didn't make sense for the timelines of how we design and build commercial buildings. Very few projects, I think, so far have taken advantage of them. If you actually know a project that's used the federal tax incentive, please let me know. Because I don't actually know of one that's gone through. The lighting incentives have been used a lot. But the whole building incentives, I know of one developer that tried to work with them and gave up. I know of 2 developers that tried to work with it and gave up. I don't know of any successful projects. But now that thing's going to be multi-year, we're hoping we can get DOE and IRS to take a look at the regs and make some adjustments so this thing becomes more available to people. And I believe it's also increased to $2.25 a square foot, not as a deduction, so you don't get that sort of economic value out of it, and you might get a third of that. And then on measured performance, many of you are probably familiar with our work with USGBC at some level. I've got some slides on the study that we completed last year on the energy efficiency of LEED buildings. We're continuing to work right now on what we call the 10 best and 10 worst study, which is going out to some really bad buildings that got LEED rating but still had very poor energy efficiency. We actually had, on Energy Star goes from 1 to 100, with 1 being the worst and 100 being the best, and we had a 1 in there out of, there was an Energy Star building. The good news is when we finally told them that and convinced them that their energy bills were incorrect, they turned it around to a 55. And they didn't even tell us how they did it, but obviously they had an operational problem of some sort. We've set up a national steering committee on measured performance, so this involves EPA, US DOE, the national labs, USGBC, various advocacy groups, and we're trying to work there to get measured performance being more important. Because as we go towards a low carbon world, again, it's not just design. These buildings have to deliver measured performance. So we've got a national group looking at that. ASHRAE is very involved in that. And then we've got a bunch of private projects on measured performance. We've got a project with the Washington Office of the Superintendent of Public Instruction to develop a system for all the new schools in Washington State to report in energy usage and other key characteristics related to the Washington Sustainable Schools Project. We've got a project with Vulcan Development and Amazon.com for a series of new buildings in Seattle, where we're trying to get in what we call key performance indicator metering system to get feedback into the design community as well as to the building operators, as well as to the people that are dealing with the financial aspects of the building. So we have 3 or 4 different report outs from a single simple set of metering technologies. We've got various other work going on there. So that's a quick run through some of the projects we're involved in. The last count I did was 27 projects that we're actively engaged in at this point in time. What I want to talk about today is just what do we know about high performance or green buildings, and some of this is really coming out of the World Business Council for Sustainable Development. They have a buildings project now, and they're looking at this issue saying, why aren't we doing better? What are the key issues? And I'm sort of focusing from some of the issues that they've framed and then working from there. And then what do we know about the energy savings of green buildings? Because this is the energy efficiency community sometimes works with green buildings, and sometimes I wouldn't say oppose, but sometimes they critique green buildings. And so what do we know about that? What do we know about the business view of all this stuff? Because these tend to be financial decisions that are made by the business community. So you can have a very dedicated design team, and that doesn't mean that building is going to be an energy efficient building, because you need to convince the key decision makers, and those might be the folks upstairs dealing with the money. And then I'll probably take a quick look at some of the information on productivity in the built environment, because again, those are things that enter into the decision-making process. So in the World Business Council for Sustainable Development, they reported energy efficiency buildings. They basically noted that the perception is that it costs about 17% more to build a, quote, sustainable building. And then they went out to test whether that perception was in fact reality. And the first one they had here, sort of reality number 1, the Fraunhofer Institute. I'm guessing that's a German organization. I'm not familiar with it. And Fraunhofer has done enough analysis. They believe you can get to 50% energy reduction with no incremental costs if you do things right. And Germany, things can be a little different in Germany. The way their code is, buildings have to be sort of narrow form, for example, to give people access to natural light, natural ventilation. So, the German example is a little different. But, there's big changes you can make with no incremental cost. The first study on green building in the U.S., Greg Katz, the U.S. Green Building Council, found 0 to 3% basically for doing a LEED rated building with a higher cost increment for platinum buildings, up to 10%. And then I still haven't corrected this slide, excuse me, reality number 3, the Davis-Langdon group, which does cost estimating, their cost estimating specialty group. I think they're in 48 states in this country. They looked at 600 buildings, and I've got some quotes from them as we go through this, because it's the language that they use is really important, but in essence, green can cost more. You can get into a building where green does cost more, energy efficiency does cost more, but it doesn't have to. And there's many ways of examining that just little piece of evidence about this. So getting into that in a little bit more detail, like it can cost more, but it doesn't have to. So that they just say, and some of these things I have in here are quotes sort of from the literature, because I think it's useful to look at how people that are inside this world talk about things as opposed to the words that I might choose to use to describe it. But there's no one-size-fits-all answer to the cost question. There's substantial evidence in the marketplace that reasonable levels of sustainable design can be incorporated into most buildings at little or no additional cost. And when they relooked, this study was from, if I go back here a little bit, 2004. They took a look at this, Cost of Green Revisited, in 2007. And once again, they had a pretty good data set of buildings. But what they found is that many projects still achieving LEED within their budgets and in the same cost range as non-LEED projects. If you took all the LEED projects and set them aside and said, what's your cost per square foot? Took all the non-LEED projects, set them on another side and said, what is your cost per square foot? These things were about the same when you look at them at this more general averaging kinds of thing. So design teams are finding out ways of figuring these things in. The second really important conclusion, and this might be a conclusion that we might extend into perhaps today's market, is that even though the construction costs were rapidly increasing, so concrete was going up, steel was going up, you'd think that the automatic reaction is, oh, these costs are going out, this new stuff, this green stuff has to go out. That's not what they found as they looked across there. They found that projects were still achieving LEED, that was still something that could be included in the project. What they did say was that if you treat green and sustainable and energy efficiency features as an add-on, you're going to have an incremental cost associated with it. You really have to look at these as integrated. And you have to you sort of have to understand that as your goal of the project has to fully incorporate these things. So you don't want to look at a building and then say, well, what would green cost on top of this design? A good example of this is I mentioned the Washington Sustainable Schools Project, which I worked on when I was at NEA, putting that piece together. And the state decided to put more money into that project. And so what they did is a school district could apply for up to an extra $250,000 for cost of green building, sustainable building, that they could indicate were additional costs on top of their normal design. Well, guess how much the average school happened to cost more to get sustainable design. And so if you set up your equation like that, that's going to give you what the answer is. When there are architects that have come in and have clearly done LEED Gold schools, daylighting, very extensive daylighting, extensive natural ventilation, high efficiency lighting, high efficiency mechanical, same identical cost or even lower cost than conventional construction. So a lot of this depends on how you set this thing up and how you frame the equation. Again, back to just a quote from this study. No significant differences in average cost of green as compared to non-green. Many project teams are building with low or no additional costs. And they had a couple hundred green buildings and over 100 control buildings. Here's a critical caveat for those of us in the energy efficiency world. That what they did say, and I think people that have worked with green know this, people tend to do a little point shopping if you're doing a LEED building. So even the best projects tend to do a little point shopping. I'll mention this one because I don't think anybody here is really going to get me in trouble, but NRDC, Natural Resource Defense Council, they were going for platinum, and they had enough points, but they were worried that you can always get a point like disallowed under the LEED system. They had no carpeting in their building. They decided to put carpeting in one room so they could make it green carpeting so they could get a point for green carpeting. And so they ended up having three too many points, but even NRDC does a little point shopping. So what happens is that you can take a system like that and you might not drive for things, in particular, again, I'm interested in energy, so lots of times these energy things didn't quite make it into the equation. Now, there have been a number of changes in LEED, probably even since this. I mean, we worked with LEED, they now have a 15% above code minimum in there. LEED 2009 has more points for energy efficiency, and they announced at Green Build last month, they're gonna start a process that will end up in essence requiring measured energy information on all buildings. It'll probably take it a couple years to roll all the way through because they couldn't put any literal requirements in right now, but they're letting people know that they're going to start collecting this data, and we're working with them on figuring out what that system's going to look like. And when it comes to real estate, commercial real estate, and you've got an excellent example, of course, here in town with the Banner Bank building, but commercial real estate and sustainability, 8 years ago, if you looked at who was building sustainable buildings, it was college campuses, it was some public buildings, there might have been a few school districts, a lot of environmental centers were in there. And the commercial real estate was, let's just say, underrepresented. If they're less than, I took a look at one point in time and only 15% of the projects in LEED were private projects. The rest were public projects of some sort. That was in the really early days. Now I would argue that in most of the major urban areas in this country, that green building of commercial real estate, by commercial I'm talking about leased real estate, especially office real estate, that's pretty much what's getting built. And that people feel they need to go green to compete in the future. And the reason is some of this information I'm going to present here, but in essence, this is a market that could really be at risk, and especially going into a weakening economy, or a weakened economy at this point in time. It's officially declared a recession now, I guess, but it's like, how do you compete? If the economy is going robust, and anything you build, any schlocko building you put up gets filled up with a tenant paying full market price, you're good to go. You can build anything. As the economy slows down, or as you try and attract, and what's driving a lot of these is when you try and attract the premier tenants in the city that you're building in. So you're building a new office tower in Los Angeles. You know, you might need to have that tower 50% leased before you can finalize your financing. So you're going to want some giant law firm that's going to take up 2 floors. You're going to want these premier clients, and all these premier clients are looking around going, hey, this sustainable stuff, it's got traction these days. This green stuff, it has traction. And they're all looking for that kind of building. And so this commercial real estate market has, I would argue that it's pretty much a flip at this point in time. I don't know that I have the data to convince people that it's a flip, but the way they're talking about this stuff, and when I talk to the big cities, I mean, everything that's going up in New York, for example, is green. And people are concerned about, is it also energy efficient? And so those are issues that are going on. But the studies that have convinced people to move, for example, this one, RREEF's a consulting group that feeds information into the commercial community. And they're saying, hey, cost premium for green, minimal to non-existent, well within the normal range of early stage cost contingencies. And when they looked at the performance, they said, well, you know, there's not a lot of evidence here. But it looks like, you know, these buildings might lease up a little quicker, they might get some higher rents, and they might maintain higher occupancy values or levels than conventional buildings. Now, if you're in the commercial real estate, these are all things that change your net operating income. These are all things that change the asset value of your building. So these are critical factors for you to look at. And then going on further, and again, I have these sort of whole quotes up here so you can see how they're talking to each other rather than me talking about these things. But you know, not very many of these have been sold, but they should trade at elevated values relative to conventional buildings. So if you're in this, I mean, the people that invest in commercial real estate, they could be putting their money in the stock market, but they've decided to put in real estate. This is an investment vehicle for them. So all of a sudden you've got somebody telling them, gee whiz, it doesn't cost much more, if any more, to make this kind of an investment, and it looks like it has a higher asset value when you go around to turn it. And it looks like if you're holding it, it leases up better, and you have lower operating costs, and you might even be able to get a higher lease. So basically the conclusion of this thing is favorable return profile relative to conventional buildings seems probable, if not definitive. I mean, my assessment of that is you're stupid if you don't build green at this point in time in the commercial real estate. So it's interesting that this slowest market is now the market, again, I'm going to argue that this is becoming an almost complete flip, and that in major urban centers around the country, the people that are building the 3 or 4 or 5 most expensive buildings in town, they're all going green. And that's the kind of things I think we're seeing at this. And you know, I don't know what you're seeing here locally, but I think, you know, Banner Bank did a lot to sort of set the stage. And their results were pretty good. And you know, locally in Portland, you know, I've worked a lot with the Girding Edlin group, and they just sold the building that their offices are in, which was a LEED gold building that was built, I'll say 5 years ago. It got the highest value per square foot that any building's ever sold for in the Portland market. And so when you see those sorts of things happening here with the lease-up rates and the low operating costs and the high asset value, this market where the financial stuff really moves around is really paying attention to this. So I've sort of got this presentation broken into a few different things. So let me stop there. If there's questions on sort of the cost and benefit and the real estate perspectives on this stuff, any just questions or comments or anything before I move into some additional data streams? Yeah?
You may have answered this since I walked away for a second. How do you get there from here if the people you're working with don't know what to do? Isn't it a question of people knowing how to do it as much as it is that it's possible to do?
Yeah. So the question is, how do you get people all the way there? And is it a question of people knowing what to do as well as the motivation? Is that fair? I think the motivation, I guess what I would argue is that the motivation in commercial real estate is now there. Anybody that's paying attention to the market forces that's in real estate for an investment is looking pretty serious at green. And then how do you get there? How do you find the right design team, the right equipment, the right whatever to make the right decisions? You know, that's becoming less and less of a challenge. If I talk to it's Paul Christensen, right, at Banner Bank, Gary, excuse me. You know, when he was doing that, he tapped some manufacturers for some, you know, out-of-town talent, stuff like that. I think the talent pool's growing though considerably all around the country. I mean, this stuff's coming on and people are getting experience in projects, and you know, there's a lot of education and training going on. So I think you know, they have to be smart about how they implement this stuff. And you really need the money and the design team to be able to meet with both of them having the same sort of motivations and skill sets. This conversation needs to go on between them. But if I looked at, again, if I looked at some of the larger architectural firms, say 5 years ago, what they would do is they would hire in at the even non-architect level a green building or a sustainability person. And then that would enable them to have a few resumes to put in case somebody asked for a green building project. And now what I'm seeing is more of a shift. We're seeing firms that are driven by principles, and we're seeing firms that have focused on green buildings actually having better growth rates than other sorts of firms. So we're seeing this sort of thing. There was an article in just this week in Sustainable Building News about how some of the architecture firms that they've talked to, that, you know, obviously we're seeing some recessionary thing that has to do with buildings, but folks that had sustainability, they seem to be hanging on a little bit better financially in their market position. So I think some of these things are, you know, again, there's a lot of market forces at work here, but I think we're seeing this transition. And I can't speak to you about how rapidly this is occurring in your market. You'd have to tell me how rapidly this is occurring in your market, but I'll tell you that this stuff is something I'm sort of seeing across the country at this point in time, as well as internationally, so it's pretty good news. I'm going to talk a little bit about the measured performance of LEED buildings, and I should get some feedback from people on how much time to spend on this, because I think Kathy Turner was up here at one point in time and gave this presentation, and I've got a shortened version of her presentation, but how many people have seen NBI's study on LEED, energy performance of LEED buildings at this point in time? I'm familiar with that. So a few of you have. So I'll take a medium amount of time to go through this one. So we got retained by the U.S. Green Building Council. First we signed a memorandum of understanding with them to sort of look at their data and understand what was going on and what was the promised energy performance of buildings, and that's one of the places where the 15% requirement beyond code came from, because we found that over 80% of the buildings were already doing that, so they weren't affecting too many buildings by making it a requirement. And then we started talking to them about let's get some real data here and see what's going on. So this report's been characterized as the first report card on green buildings by at least one outside resource. So we're going to look at this in several different ways, relative to LEED points, comparison to some other metrics, and I don't have a slide in here on modeled versus actual performance, but I can sort of describe that briefly. So at the point in time we looked at this, and basically this study was wrapped up a little more than a year ago. It wasn't produced, I don't think, until March, but we had all the data more than a year ago. We had about over 500 buildings that had at least 1 year's worth of energy bills, and so that was our sample size. And the first conclusion out of this study is, you know, we're only able to get 121 of those buildings. Only 22% of those buildings could provide us with energy bills for that year period of time. Now, some of them have pretty good excuses. You know, you're a tower with different tenants and you've got tenant metering. You're a college campus building and you're on a steam plant. You know, so some of them have pretty good excuses. Some of them have no excuses. And so our first finding was getting this building information, it cannot be this hard. And that's the reason for the announcement this year at USGBC that you're going to have to start providing us with measured information. And if your energy bills don't cut it, I mean, the program we've proposed to them, and again, we haven't worked out the details, so I'm not trying to anticipate that all this stuff will happen the way we envision it, is that within 2 years, you have your choice of either being able to feed in a stream of data off a utility smart meter system, or you're going to have your own metering system in place feeding it into the internet so that this stuff can be tracked in a database. That would be our recommendation to them. I don't know if they'll go that far, but I really, if they want to maintain the L in leadership, I think they're going to need to go there. That would be my suggestion to them. And some of the benchmarks we took a look at with these buildings was comparing them to CBECS. CBECS is the Commercial Building Energy Consumption Survey. So that's a large national survey that they do about every 3 years. It's got, I think, 6,000 buildings internationally, comparing them to Energy Star, and then we compared them to the original modeling. So this is the CBECS data. And maybe I'll use my, my little arrow here. So those of you that aren't familiar with these parameters, the energy use index on the left, it's BTUs, kilobTUs per square foot. If this is not in your language, I'll just say that 100 is like average, sort of mediocre, and 0 is where everybody's talking about going. That's like 0 as in net zero energy use. So you just put this in a 100 to 0 framework and you'll be okay. So what's interesting is that across all these years, so the buildings that were built in the 1920s, buildings that were built in the 60s, buildings that were built in the 80s, and then these studies are done every so often. I see that little bump's not going to help me anything. Maybe that'll go away after a while. There we go. So these studies, this is a 1992 study, 95, 99, 2003, you can see the lines. But basically, this building energy use has kind of stayed the same or actually gone up a little bit in some cases. And this most recent one, of course, the most recent report, we only have one report on those most recent buildings, energy use actually went down a little bit, down to about 80 on this, 0 to 100 kind of scale. So despite new building codes, despite advances in energy efficiency and products, building energy use really hasn't changed too much. And part of that is that in some cases we use our buildings more intensely. I was speaking in New York City a few months ago and I got into the airport really late and it was 2 a.m. and I was going through the streets of the financial district and there were limousines double parked all along the streets of the financial district. I said, what's going on? There's some big party here tonight? It's like, no, it's like this every night. They're here until the markets close in China, and then they go home. So it's like this every night at 2 a.m. So these buildings are not being operated on an 8 to 5 schedule. So you've got that. Then you've got all the computer stuff we load into buildings, and you name the building type. Compare a McDonald's to a Ma and Pa cafe in terms of energy use per square foot, and the energy use is quite a bit different. So these buildings haven't changed that much. What we did when we looked at this is we classified buildings into high energy use and medium energy use. And I was surprised, we found out after the fact, my staff did this and didn't tell me about it. I said, well, who else uses these? Well, nobody else uses these. Medium energy use buildings, I would argue, are buildings where the primary function of the energy use in the building is to provide comfort and support human occupancy. So an office building, a retail building, those kinds of buildings where most of the energy is there for human functions. Now, a good example of a high use building would be a restaurant. So most of the energy use in a restaurant is used to cook food. Most of the energy use in a hospital, who knows where it goes, but it's a really high number. You're in a lab building, you've got a really big number. Even in a grocery store, you've got all this refrigeration going on. So we sort of classified these as high and medium use buildings, and most of the rest of our analysis is on medium. But here's what we found. So every one of these bars represents a building. And again, we've got the 0 to 100 scale on the left-hand side here. And the CBECS average is 91. So that, again, that's our national average of all these buildings of all different vintages. How do we compare? And you can see if you, any Europeans here, you can get the kilowatt hours per meter squared. But how are we doing? And in general, on average, our buildings averaged out at about 69 overall, 69 kilobTUs compared to 91, so that's good. And the medium energy types, again, these ones that didn't have these particular high use were about 62. And you can see, and I've got more detail on this, that gold platinum buildings did better than silver and did better than certified. But there's a couple of things to look at here. One is this huge range of these buildings. We took a relatively narrow set of building types, and yet we have this range up to 140 kilobTUs a square foot down to less than 20 for building types that are in essence kind of similar. So what's the reason for that? And these questions couldn't all be answered by this study. And then you see, again, silver and gold are kind of interspersed in silver. So you see that there's a lot of things there. But this huge range is sort of one of the key findings out of this. And then when we look by building type, so this is really much more useful. you can see the blue, let's see, the diamonds are the all vintage CBECS data. And I remember I showed that we had a little drop in energy use for the most recent CBECS, so they're these blue squares. And then the green are the LEED buildings. But you can see that for every building type we looked at, the LEED buildings did better. And even if we compared them to the most recent CBECS data, they still in general did better. Now this is a small sample size. I've only got 120 buildings here. And really, if I want to be robust in my statistics, the only one of these that's really robust is offices. We had a lot of office buildings. But their pattern is very typical of all the other buildings that we saw, that we're seeing these pretty significant energy use reductions compared to standard building. If you tried harder, you did better. And this is really a key finding. So if you were trying to get more energy efficiency points, so 10 was the maximum, then you did better. And if you really aimed really high, 8 to 10, that's an average 42 energy use index, 42 kilobituses per square foot. That's an excellent number. That's a very, very serious building. That building would meet the 2030 challenge goals for right now, which I know all buildings are supposed to meet that goal, but really only about 1 in 1,000 does, and that'd be in 1 in 1,000 is at that level. If you look by climate, you guys are okay here, but if you're in Houston or Florida, you got problems, because in warm, hot climates, it's not clear, again, small data, but these are more difficult climates sort of to figure out sometimes from an energy efficiency perspective. We did okay in the other climates. Again, we found these things true to be across climates. Now, Energy Star levelizes buildings. So if you've got a 0 to 9 or a 1 to 10 Energy Star score, you're in the lowest 10% of all buildings averaged out across the country. So therefore, the grays in the back of this graph are 10% of the buildings are 0 to 9, 10% are 10 to 19, et cetera, et cetera. And these are normalized for occupancy patterns. They're normalized if you have a data center, if you have a parking garage. So Energy Star takes all the normal kinds of things that affect building energy use and it tries to normalize these things. And it's normalized by climate. And so here's what happened with the LEED buildings, which are the green buildings. I mean, this study was really good news, bad news for USGBC. The good news was in general, they did better. The bad news was they had some terrible buildings in here. You're a LEED building, and you're at lower than a 50 Energy Star score. I might argue lower than a 75 on an Energy Star score. What we sort of found here is that, about 75% of the buildings got a score of 50 or better. So only 75% of these LEED buildings were actually better than the median building in the country from an energy use perspective. That's not good news. These 25% to the left, they shouldn't exist. And then if you looked at this a little closer, you needed an Energy Star score of 75 or better to be an Energy Star building. And only about 50% of these buildings would have met that standard. So, what I would have hoped to have seen in this graph is that everything would have been an Energy Star or better score, and that's not what we found. So this is sort of the biggest bad news, is that we're not getting, on average, we're getting about 25% savings with LEED. In any particular building, unfortunately, you could be anywhere across the map, and that's the difference between design a building for energy efficiency and the actual performance of that building, and these things can be very substantial. Energy Star score, again, the good news here is that the harder you tried for energy efficiency, the better your Energy Star score was. So if you were shooting for 8 to 10 points, you were at least on average better than you'd be an Energy Star building on average. So that's some good news there too. And I already mentioned this building that went from a 1 to a 55. Because we get this 1, it's like, what is wrong? And so we have to know what's wrong. It's like, did you forget that your building was twice as big as you said? So we kept calling these guys going, and they kept saying, oh no, we're fine. We're getting fine. And then we said, you are in the worst 1% of all buildings in the country. And they said, we are? And then they went and fixed whatever it was, and they ended up being a 55. So this just demonstrates, I think, the importance of feedback loops in these buildings. So only 22% of them could actually give us their energy bills. And this was one of the ones, obviously, that did give us their energy bills. So, you've got all these people out there that have really pathetic performance because they don't understand the benchmarks or what they should be achieving, or they don't think about what was designed and what am I getting, and they don't look at these things. So we're missing this feedback loop, which I think is really critical. We also looked at these buildings on occupant comfort. Again, a little bit of a, we don't have very many buildings in this survey, which is disappointing. Again, we had 120 buildings, but each one of these little diamonds is a point. So you can see we only had about a dozen or so buildings in this thing. But in general, these buildings did average on acoustics, pretty darn well on lighting, temperature, and air quality. These red little arrows are the buildings in use average. Buildings in use is a Jacqueline Vischer of the University of Montreal as a protocol, and she's done thousands of buildings with this. So that's sort of an average for other types of buildings. So in general, pretty good scores on occupant comfort, although not much change on acoustical comfort, but the data set's very small. I would say the Center for Built Environment at UC Berkeley has done similar work, and their results are fairly similar to ours. We had a little better score on lighting than they did. But you know, the LEED buildings appear to be offering a better occupant comfort, although again, data is still a little limited. So just to summarize here, I mean, the big things are that, you know, they did achieve savings with LEED buildings, but there was really a wide variability, and we don't know why, and we're not sure how good the modeling was, and we don't have this feedback loop back into the owners or the managers or the people that should be caring about this building. And we probably need, you know, again, as our recommendation to USGBC, you got to fix some things to support better performance of LEED buildings, and they're beginning to address those things now. Since we're, you know, we sort of had our 0 to 100 range, I wanted to present a little bit more data for you here. Just we've had a couple of studies done recently that I think are useful, and one of them was there was a Northwest study, so you guys would have been involved in that, although it would be dominated by Washington State. And then I made a trip to Germany here a couple of months ago, and got to a better understanding of a program that they've operated to support really low energy buildings, and what have they achieved at this point in time. So on average for new buildings, for offices in the US, again, back to our kilobTUs per square foot, or for those of you that don't have that, our scale of 0 to 100, you know, the US buildings are around 88, and find that arrow again. And Northwest was a little bit higher than that. And this number might have been slightly artificial because one building had a fair-sized data center in it. So it could be that, if don't look at this and think that Northwest buildings are worse than the US average, because they're probably not. I think this was influenced. But what was our LEED buildings? What we found in our study was that offices were averaged around 62. In the Northwest, there weren't a lot of office buildings, but they found that they averaged around 60. So the Northwest study, this was completed by Dave Balin at Ecotope, for those people that know him. And I've looked for this data inside their final report, and I can't find it. So this is an updated version of graph 12 of his ACEEE presentation. And you can get this from David Balin or from me, and I don't know where else it exists, but this was his data that he presented at that conference. If I can find my arrow again. Now, the German prototypical buildings, and these have been built for a few years now, were then about half of our LEED buildings. So they're around 30 kilobTUs per square foot. So that's pretty darn good building. But this lets us know maybe a little bit more about what's possible today with these. And then schools, you know, we have a kind of a similar story. In this case, the Northwest buildings on average, the new Northwest buildings look a little bit better than the new US buildings, which makes more sense. And there are only 3 or 4 schools in the Northwest study, but they average a remarkably low 33 kilobTUs per square foot. So I know of a fair number of recent green schools. They happen to get lucky, I would say, with these 3, because that's a pretty low number. I wouldn't necessarily expect it to be that low. But then the Germans did better, and they were under 20 with their school buildings. So this sort of gives you the idea of what our average practice is compared to what our sort of, I shouldn't call it better practice, maybe we'll just call it best practice. And then while the German example doesn't quite translate, I would argue that that's really best practice type buildings. If you really focused on it, that's where we know how to get to today. And those German buildings are a few years old, so it could be we can do better than that. So just to give you some perspective there.
Dave, do you have any sense for how many buildings are in that German study?
Yeah. I think right now there's about 17, 20 that they have the final data on. They completed more buildings than that, and for some reason they don't have data on all those buildings.
Demos or demos or demos?
Demo buildings. These were demonstration buildings. Okay. So it was a...
I was trying to play German there, you know.
Yeah. Yeah, but you're a Vanden, not a Vonden, Wibellenberg. So that's Dutch, not German. You can't fool me there.
Another question from online.
And we had a few questions from Amy down in Arizona. Going a while back, the Portland property that received a high dollar amount.
Yeah.
Is there any documentation on that, or how can people find out more about that building?
Boy, I mean, I remember reading the newspaper article. I assume it was covered in Sustainable Industries Journal, so that might be one source.
Do you remember the name? Was there a name for the
The
building?
name of the building, well, this would have been Brewery Blocks. I believe it was Brewery Blocks number 2. 2 or 3. Yeah. I think it was Brewery Blocks number 2.
Okay, and then they had some questions on how to get some of the reports when you just went through all your lead comparison in that lead study.
Yeah.
How do people get that? And they were also wondering, I don't know what this acronym is, but the RREEF
Yeah.
report, is that available to the public?
It is. At my final slide here, and I can go to this right now, just to go all the way back, because it's here. So our website is newbuildings.org, and so you can go to newbuildings.org, and the lead study is fairly prominent. And then if you go to newbuildings.org/measured performance, what we have is a little listing of maybe 30 measured performance studies now. And some of these are financial studies, and some of these are productivity studies, and some of these are energy-related studies, and those studies are in there. And if you're interested in financial, we even have a little search engine. You can say financial, and it'll track you to these. So like the RREEF study is in there. The CoStar study, that's another well-known study in the financial community. It's referenced in there. All of these studies that I referenced earlier in my initial document. So newbuildings.org/measure performance is where you can find that stuff.
I have a question about the slide we were just on about the German, I think was that the energy use index.
Yeah.
How much do you think is related to our codes versus their building codes?
I don't have a sense of that. I was only in Germany for a short while, and some of the things I wanted to do, you know, you get there, I spent like 2 days over the weekend and 2 days at the conference, and basically you're recovering from traveling to Germany. It takes a long time to get from Germany from here. I was stunned. For a while I worked in London, and it was like an easy commute compared to like going to Germany. It was unbelievable. It took me 20 hours to get back. So you're kind of shot. So I was hoping that I could like tour some buildings and get a better understanding of this stuff, and I did not. So what I can say is that the Germans' best practice is probably better than our best practice. And I have no idea where their good practice is or their average practice is, if this stuff has resonated within the community. But they do have some things that are different. Let me give one anecdote, and that's just that there's a building, the Genzyme building in Cambridge, Massachusetts. Well-known building with an outrageous daylighting design where they bounce in daylighting through computerized mirrors at the top into a central atrium area. And I met the architect that designed that building, who's, I don't know if he might actually be Dutch, but he was at this German conference that I was at. And he said, oh, they went over there and they said, well, we're going to build a German building with our thin, you know, we're going to be a thin building, you know, and therefore maybe we'll do, you know, a couple of thin towers on here. And they go, oh no, we're Americans here. We own the block. We're building the block. We're building the block out. We're going up, not skinny. And so this design of bouncing the daylight in, that was the German or whatever, the European solution to not being able to do a thin form building. So they do have these thin form buildings, and I don't have that data. I can't actually talk about that. And I would like to be able to talk about that, because as we move in this country, we're going to need to see if there's other places in the world that have lessons for us. And you know, there are different places, I think, around the world where we can learn some lessons. I'm going to whip through just a few findings. This is sort of a miscellaneous slide, but I think it's, as we try and move to what I call the next generation of buildings, what do we know so far? And for buildings to get to 50% energy saving, it's only about one building in 1,000. And you know, best case, maybe now it's one building in 100. But it's not a very high percentage of buildings. And we've looked at these, and the good news is that this is possible in multiple building types, multiple climate zones, multiple design teams. And so this is doable. You don't need a national lab holding your hand to create one of these buildings. This is doable. So it's a question of moving skill sets into other people. And importantly, it's a question of moving motivation. These buildings are largely driven by the owner. If I took a look at the 100 top energy efficient buildings in the country, probably 90% of them are strictly driven by the owner, and 10% of them hired some firm that had a superstar architect or something like that sort of ended up driving the process, and the owner just said whatever. But 90% of them are just driven by the owner. So it's the owner's interest that's really driving these buildings. And the big issue is how do we move this stuff forward? So now I'm going to go into just a few issues that I see, and these are just things that I'll explain a little bit. And this one sort of comes from the German experience. So they have something they call HVAC plus L. And so this goes back to buildings being there to support human functions. What is it about the building energy use that supports human functions? And I would argue that we need HVAC plus L plus plug loads, because plug loads sort of support human functions. But when we're looking at building energy use and we're really starting to squeeze down, we probably have to take some things out of the equation. You got a little data center in the basement, we don't want that when we look at your energy use index. You have a restaurant in the first floor of an office building, we don't want that when we're looking at your energy use index, because that's different. You got a big parking garage on your meter, we don't want that. So we might need to focus on really fine-tuning our energy use so that we're not just looking at a utility meter, we're looking at some other different set of a few critical meters around the building, so we can take out some of the kitchens, we can take out some of these data centers and get to something that's really a measure of how that building is performing. Bill Bordis from the UK says it's energy used by the building, not energy used in the building, is how he articulates this. And I think that's a useful way of thinking about it. You can have any sort of energy use in the building you can imagine, but what you really need is what's the energy used by the building to support the functions of the humans in that building. That's the number that's kind of critical here. Because this other stuff falls outside codes. It falls outside design parameters. And if we keep it outside, then we might be able to focus on it a little bit closer and say, all right, well, what do we need to do with garage lighting? You know, what do we need to do with restaurant equipment? So that's one thought. The next thought is DOT, and this is design, operations, and tenants. Because any one of these can basically kill the building. You know, tenant loads in office buildings are probably, the plug loads are probably 15 to 30% in most office buildings are now, and that's strictly a tenant load. So that's kitchen equipment, that's office equipment, that's cell phone chargers, that's speakers, you know, that's all the stuff we have in our offices. There's a lot of it. And operations is just a critical driver. If this building doesn't operate well, it doesn't matter what you put into it. Actually, the more complex system you put into it, if you don't operate it well, the worse the building gets. And the 25% worst buildings in the US have some of the most sophisticated equipment in them because people don't know how to control them. And so they fall down. So we can't drive all of this from the design side, because that's sort of what some people are thinking today. We can drive this from the design side. Not going to happen. We need to look at all three aspects of this. Human factors. There's not quite enough attention paid to this, but the reason we have buildings in the first place is to make us more comfortable, more productive, healthier, all those sorts of things. And if we ignore that stuff, it was interesting going to Germany, because I focused on this, those of you that know me, I focused on this a long time ago, and I spent a lot of time with Carnegie Mellon University where they track all this stuff. And then this hasn't gotten that much traction in this country, and I sort of forgot about it. I went to Germany, it's right there in Germany, it's right up there. What are these human factors? And frankly, they found that a couple of their low energy office buildings, they had thermal comfort problems in the summertime. They had an extra hot summer in Germany. As we know, they might continue to have extra hot summers if things keep going the way they're going. And they had substantial thermal comfort problems, which probably impacted productivity. But at least they're tracking this stuff. We're really not at this point in time. And then the final one, as we move the ball forward, is I'm not necessarily anticipating that we've got sort of linear, little sequential little steps we're making on the way to energy efficiency. It could be that there are some really big moves we make. Thin form buildings is a big move, for example. That's not slightly better mechanical system. That's changing the nature of your building form to improve access to the outdoor environment. That's a huge move, and we might see that kind of thing here. We might never see that kind of thing here. But there's probably things we can't anticipate. So one of my thoughts is, since commercial buildings take such a long time to design and then construct and then to get occupied and then to get billing data on, I mean, we can be looking at 5 years here. We're almost certainly looking at 3 years from even a quick design construction, you know, get a year's worth of building data. That's probably, you know, I've seen it done in 2, but let's say 3, but for a big building. But it could be that what we need to do right now is push for absolutely leading edge buildings, not incrementally better buildings, but really leading edge buildings, because those will be the ones that will be the lessons that we can bring back. If we do incremental advances, our progress is going to be substantially slower, I believe. And we could be making advances on things that we end up throwing out. It could be that we really focus on advancing the efficiency of unitary systems on buildings, and it could be that we're not going to want those if we try to go to a really low energy building. We might need an entirely different system. So I think it's maybe important for us as we think about this from a research and policy perspective is to jump way ahead and sort of do what the Germans were doing with their demo buildings and then filter those lessons back into normal construction. Because if we just do this incrementally, our learning cycle is going to be too long. We're going to have 5-year learning cycles, 3 to 5 year learning cycles. We need to speed that stuff up rapidly. But wait, there's more. Let me just stop there then for a second. This might be a time to take a few other questions or comments from people. Yeah, Kurt.
What was the funding for the Germo demonstration buildings? Do we know that? Was it federal or some other source?
It was federally driven, and I'm not sure of the funding mechanisms. I've been trying to track down some of the documents. I might need to find a German translator to help me because, you know, the most basic stuff is in English, but I haven't found sort of the source documents that explain the program operation. I do know the guy that's like the star of this program, so hopefully we'll bring him back to the U.S. at some point in time to talk to us about how they structured this thing, because it's, well, I got to go back one. Somebody asked the question of what's this done for average performance, and that's the thing I also don't know. So they've got these good demo buildings. If it hasn't impacted what's happened in Germany, then what's the point? So we need to connect all the dots to move this thing forward. Yeah, but
Is Stefan Vanish using these principles in his Advanced Science Center in the Alston Initiative in Cambridge, or near the Genzyme building? Do you know?
I have no idea. No, I don't know anything
They are
about that.
German architects, Vanish architects are out of Stuttgart.
Yeah, well, that might be the gentleman that I saw present.
yeah.
I'm not sure who that.
But that's, I saw the model of that, and it's 4 big buildings around a courtyard within.
They do a lot of what the Germans have done is a lot of courtyards and sort of unconditioned atrium spaces that are usable perhaps for 6 months of the year. But it's interesting. Germans have a little different relationship with the outdoor environment than we do. So I'm walking down a German street. It's say 45, 50 degrees. There's a little moisture blowing around in the air, and people are sitting outside at sidewalk cafes having breakfast. And you wouldn't see that here. I mean, that's Portland weather. You would not see people sitting outside in a cafe at 7 o'clock in the morning having breakfast when it's 50 degrees outside. So the idea that they have these atrium spaces, some of the initial buildings that I'm familiar with, and I know the architect on those, they had these large, they'd have like a U-shaped building wrapped around an atrium. And I have talked to some US designers now that are looking at very low energy buildings, and they're kind of they're looking at that as a model because it takes a significant percentage of your skin out of the equation of the building, and you still get these that can be pretty nice spaces. The fact that it's unconditioned still might make it a very pleasant environment for 6 or 8 months of the year. You know, there might be a period of time where it's way too hot or way too cold. But that is a common strategy. That is one of the strategies I've seen there. Yeah, yes?
Do you guys look at the plug loads on buildings and see whether there's ways to go to, moving 80% of the computers into a data center or cloud computing or some other?
There's amazingly little information on plug loads right now. We're working on a project, I may have mentioned this earlier, Office of the Future, that was started by Southern California Edison. It's funded by 8 utilities now across the country, and NBI has just been selected to be the fiscal and management agent for that program. But one of the things we really dug into is plug loads. And we basically were able to cut the plug loads in buildings, it appears, in half by using timers and extension cords with occupancy sensors on them, taking out bad refrigerators and doing a few other trivial things. The payback on reducing plug loads ranged from, I think, 2 months to like 3 years. I mean, it was the payback on the plug load stuff was really inexpensive. But there's ECOS Consulting should be releasing just this pretty soon a study on plug loads on the commercial side that looks more theoretically at them. And we have a proposal into the California Energy Commission to actually go into a series of office buildings and take all of our best knowledge on plug loads and go in and convert them and convert them to best practice and measure what happened. So that's, but plug loads, I was shocked at how little information we have. There hasn't been much in the way of surveys, and we found one study that had pre and post data of trying to do something in plug loads.
Have you heard of Climate Savers?
No.
It's an alliance that has Google and Intel are the founders.
Okay.
And that's their focus,
Okay.
is coming up with more efficient computers, being able to turn them off when they're not being used.
Yeah.
All that stuff is their thing.
Well, I should check into them, because we are trying to bring more industry into our next phase of Office of the Future, because we're trying to go deeper in all of this stuff. And there are computer things that are going to, thin client computers instead of desktop PCs might be the next model. But you need to make these investments for reasons other than energy efficiency. You wouldn't want to go to a thin client just to save energy. You want to go to a thin client because it enables you to upgrade your software and keep everybody on the same basic software over time, because there's a cost to doing all these things. And there's things you can kind of do from an energy efficiency perspective, and there's things you're only going to do from an IT perspective. So it's an interesting balance. But IBM has they have some sort of a green team that's focused more on data centers and big things. And they keep going out there and sounding the alarm, saying, your IT energy use could go up 8 times faster than any of your other energy use. And they are sort of sounding that alarm. Green, yeah. So that's going on. Was there another question? Yeah.
Back on that study where you looked at 120 some odd buildings, and you mentioned the one that was the 1% down at the bottom of the barrel, and you apparently gave them some feedback. I'm just curious about all the other building owners. Did they receive copies of the study and feedback on their particular buildings?
They did. We did give, as part of the reward for participating, we gave them information on their performance. We have not followed up to see if there have been any adjustments to that. I will recharacterize that last thing in that we are now engaged in a study called 10 Best, 10 Worst, where we're going and looking at 10 of these really excellent performing buildings in the USGBC study and 10 of the worst buildings and say, what happened? What makes a building really good and what makes a building really bad? And I'm just going to get my first look at that data next week. But the first phone calls found out that the operators, the building operator and the buildings that were really good were completely dissatisfied with the energy performance of their building. And it was that striving for perfection or a better number and knowledge of what was going on. I mean, if you go to talk to the Center for Neighborhood Technology in Chicago, which is an organization that we work with a fair amount, but they redid their building and they have little ice storage balls and they have all this really slick stuff going on, and it drives them nuts that their pump is oversized to deal with getting heat or ice or coolth out of the ice balls. Drives them completely nuts, and yet they're a top performing building. So we did find that piece. On these low performing buildings, we don't know. And we might find, and we hope we do find, that we go to some of these low performance buildings that said, oh, you guys gave us some feedback, we made some adjustments, now we're not so low anymore. We'll see if we find some of that stuff out. I'm going to take maybe one more question, then. Did I have a question over here before I move on? No? Okay. Well, let me move on just to a few more things. I've really just got a few more things here. But when we talk about business outcomes, energy is really only a small part of the equation, especially when we broaden beyond energy to sustainability and green building, which I typically do in talking about this, because I believe it has a lot more marketplace traction. So, on the financial end, you have some performance improvements, you have increased resale value of the property, enhanced ability to rent, and reduce costs if you have better energy performance. So those things are all pretty straightforward, but taken as a whole, they're important. On the human resources end, again, in a down economy, this one might get a little fuzzy because it could be that everybody's willing to take any job, but we've got a lot of people coming out of college these days that when they go to their interviews, they're asking like, well, what is your carbon footprint? And what building will I be working in? And do I have flexibility to work from home twice a week, or what's the deal here? And they're starting to ask these kinds of questions. And so the human resource departments of a lot of these large employers are beginning to address some of these things. And then there's a fair amount of studies in terms of the well-being of workers due to improved mood, improved comfort. And I'm going to reference a few of those here very quickly because I think those are useful. But then there's this whole thing on stakeholder and customer relations. So, a good example of this, couple of good examples are Starbucks and Nike. So, you know, these are folks, Nike in particular took some shots there for a while for, you know, how are you dealing with your labor force in China, and who's doing this stuff? And Nike has attempted to address these through some serious activities on their behalf. It's not all just PR. It's not packaging. You know, they've made some adjustments to what they do, and you've got a lot of other organizations that are looking at that and trying to increase their ability to sell to those pro-environmental customers, or trying to do something on their public image. And you've got a lot of folks that are, you know, reporting now on, you've got a lot of large corporations that report on their carbon these days and report on the activities they've done. It's part of their stockholder and stakeholder kind of reporting. So we're seeing all these factors that are being part of the equation. And so it's important not to just focus on, you know, I focus on energy, but I see this market more broadly. Don't just focus on the energy and how we define cost effectiveness. Look at all these other kinds of things that are going on here. But if we look in particular at this comfort, health, and productivity, this is back to my work, you know, with Carnegie Mellon. I shouldn't say my work, their work that I take advantage of when I can. But basically, when they looked at buildings, they said, you know, a lot of these things that are in buildings that have to do with energy really have an impact on the people inside the building. If you look at the things that have an impact, they looked at other things like ergonomic furniture. They looked at, you know, some other kinds of elements, but the presence of daylighting as an architectural feature, very important. The quality of the electric lighting design, extremely important. Personal control of electric lighting, extremely important in productivity and comfort. Adequate or more than adequate fresh air. So what we say is adequate. If you give people more, they actually like it better. Temperature within a defined range, and personal control of fresh air and temperature. So this is like, you know, I have a car where my wife can set the temperature different than me, and we can turn the seat heater on or not turn the seat heater on, and all that sort of stuff. You know, you get in a room, you know, you get in one of these cells, you know, all these people working in their own little office environment. You know, there's one thermometer in the entire room, and if you don't like it, you're either too cold or too hot. And so what do you do about that? You know, if you're too cold, you go get a plug-in electric heater and put it in there if nobody catches you, and you add to the plug load of that building very significantly. And if you're too hot, you go to sleep. You know, so you got to watch this stuff. So this personal control stuff is really important. And then seeing a pleasant view. Of course, this is not always an option for people to have a pleasant view, but some view of nature is really pretty critical here. And people say, well, where's the data? Well, the data is at Carnegie Mellon University. And just to give you just a few examples of what you can find there now in the BIDS database or the eBIDS database is, you know, lighting design and individual productivity, average gain of 4.6%. And they have a whole series of studies then that support this. And you can see some of them support it, you know, more rather than fewer, but you don't see anything negative here, would be the one thing I'd point out. Daylighting, these are the daylighting studies on the left. The first two, for those of you familiar with the literature, are the Lisa Heschong's study, first on stores where sales were up by 40%, and then finally on classrooms where learning based on standard tests was up 18 or 19% for elementary school students. But you know, those aren't the only studies in the universe. They're the ones with the highest numbers, but you don't have to believe those numbers. But somewhere along here, you know, there's a big impact of access to the natural environment as it affects productivity. And if you look at these things from any sort of a financial equation, you know, the energy cost savings of this advanced design stuff are just dwarfed by the productivity and or the health benefits. Yeah, I don't know what Carnegie Mellon's number is now, but when I was there, they had a number of $825 for a migraine headache. That's how much it cost. If somebody has a migraine headache, that's the lost work time due to a migraine headache. So if there's something you can do with your lighting design or something to keep people from getting fewer headaches, that's good. If you have a comfort complaint, it costs a building owner $600 to completely resolve a comfort complaint. No, so if you have individual control of the comfort, you probably don't have a comfort complaint. So that's $600 times that. So you've got these sorts of factors that really translate into the business value of all these things, which I think is eventually where we're going to get to. Like I said, I worked on this a few years ago. I let it go for a few years, and I'm back to it again because I think we're going to see this stuff coming in.
Dave, is Carnegie Mellon, is that BIDS database, is it still have funding? Is it getting updated? Do you know anything?
It is getting updated to the best of my knowledge. I'm no longer a member of the consortium, but they have continued to develop that information and tried to figure out how to package it up. Because it used to be you could take their individual studies and apply them, and I tried to roll that out and that didn't work. But I think the idea that you can look at 15 studies on electric lighting design and say on average these things are 4.6 better, that's an easy thing to translate to people. You know, it's just like, this thing's gonna be good for you. So they've got better packaging on their information, and they continue to update, to the best of my knowledge. There's new studies in there. So the key thing here, I guess, on some of these things is, do we have absolutely perfect data on any of this stuff? Well, no, we don't. You know, we've got holes in our data. We don't actually know that much about the performance of new buildings, because our studies are a limited data set, but we have some information. But the question is, are people ready to act on this data? And I think the answer is largely that they are. And so here's, this is sort of my summation of the picture. You know, the cost of green and high performance buildings, modest to non-existent. But the real estate community thinks that the financial benefits exist. They're beginning to act on this stuff. And I think we're going to see that translate into people that were, 10 years ago were more interested in this stuff. Now it's like, what are we going to do with schools? What are we going to do with public buildings? What are we going to do with these things? I think this, we've got one market that's really moving here. I think it's going to drive a lot of other activity. Energy savings are substantial in green buildings, although quite variable. Productivity improvements, I would argue, are real and proven, and those are things that people ought to be taken into account. The business community is beginning to act on these sustainability things, and as I look through back to the initial thing where I talked about commercial real estate, what we're now seeing the issue come up of within the commercial real estate industry, they're talking about brown buildings, because these guys don't own just new buildings, they have portfolios of buildings, and they are extremely concerned about what to do with what was a Class A building that's now 15 years old and does not have the environmental features of this new building, and they think they're going to have trouble renting it and repositioning to the market. And that's one of the things we're trying to take advantage of with our Office of the Future project. So I think that's it. Again, this is for a lot of these measured performance studies, we're going to redesign our website somewhere down the line to try and make these more accessible, but if you can type this stuff in, you'll find it. So that's what I've got. Thank you very much for the opportunity to come here tonight.
Yeah, excellent. We have time for a couple of questions.
Another question from Amy down in Arizona, and maybe someone in our audience could help too if you don't know, Dave. Apparently the USGBC does not consider a view into an atrium as a view to the outdoors. Mm-hmm. Could you comment on that at all, or any experience with that?
I don't know.
I think it's true, but beyond that, I don't know.
Yeah.
Other questions for Dave? Steve?
You mentioned the idea of getting some buildings that are kind of leapfrogging ahead as far as energy efficiency. And do you have an idea of how to accomplish that? How to incentivize people to build buildings like that?
Yeah, I've got the beginning of an idea on how to do that, and this is a proposal I'm going to make to this 3-state Pacific Coast group. I haven't made yet. So, but basically, I think you want to pick a measured performance energy target, and you probably don't want to exclude back to that HVAC plus L, maybe plus plug load. You want to say, I want to measure this aspect of the building, and then I think you take a sort of a typical probably utility incentive type program, and or if you have some state tax incentives layered on top of that, you put on this measured performance element with an incentive on the actual measured performance aspect of that. So the incentive actually wouldn't flow. You might have some additional design incentives, but most of the incentive wouldn't flow until you've got the building information. And you'd put that out there on top of that. And from a study perspective, I would include, metering these buildings up from the get-go. And in essence, creating a fleet of case study buildings. And so if we could get, say, 50 or 100 of these buildings around the country, we'd have an amazingly rich data set to pick from. But I think what you'd want to do is sort of layer this on top of existing programs, because there's a lot of good stuff that's going on out there right now. You don't want to create some new pathway, but you do want to create some additional incentives beyond that. And I'm going to try and talk people into doing that.
Have you done any research on buildings that have been modeled energy-wise versus what they actually performed?
Yeah, and that's part of our lead study, and we have some separate papers on that as well. There's a detailed paper. If you get the ACEEE summer study, does that ring a bell for you at all, or anybody here have that? But in our lead paper, if you go to our website and look at our lead paper, we have a section on modeling. And the short story is that it's a complete shotgun. Actual modeling results compared to actual measured performance have almost no statistical correlation between the two. And that's the second time NBI has gone out and done a study like that. With this one had better correlation, but a long way from statistically valid correlation. So it's almost a complete shotgun. On average, however, the buildings perform pretty much like the model said. So if you add all the models together, for the lead buildings, the model said, 25% better. If we added all the energy performance, we got 25% better. But if you compared any individual building, it's completely, in essence, it looks like a random event. So, you know, we're trying to do some things to tighten that up, because some of these are early lead buildings, and so, you know, there's some places in the country where modeling was done a lot, and there's places in the country where modeling hadn't been done hardly at all. So some of this is inexperienced modelers. Some of this is, you know, weird parameters. There's probably some things we can do to clean those things up. And, you know, the Europeans are going to a system that has an asset base, which is in essence a modeled energy base, compared to a performance base, which is an actual measured performance base. And if you can't get this modeling to have better than this random correlation, then this never makes any sense. So we're probably over time going to tighten up some of our parameters and maybe some of our rules around energy modeling to see if we can get these things to look more like each other. But again, the problem might, who knows how much of the problem is on the modeling side. You know, we're trying to get some indications of whether it's a modeling problem or an operation problem or a tenant load problem or another problem with the study we're doing, but it's statistically nobody's done that work any more than we have. So we're really at the very early stages of understanding why these differences exist. People have a lot of opinions, but there's very little measured information about why this almost random distribution of model to actual performance results.
On the modeling piece, I'm curious, have you looked at how involved the modelers were in like an iterative process throughout the design versus someone that just came in and modeled the building for the lead?
No, we don't have any of that kind of qualitative information, really. Yeah, I don't know what to say. Again, I don't want to say that modeling's a problem. All I can say is that modeled energy use versus measured energy use are not really directly related to each other. So it's why we don't really know yet. Yes.
Of those 10 buildings that you said had these, you know, really competitive operations people.
Yeah.
Have you looked at that, the models for those versus the performance?
We haven't. I mean, these are all really good ideas. I don't know who's on your web, but this study we did for USGBC, we started with 40 grand to do a national study on these buildings. Now in the end, USGBC, we'd say, hey, we got a problem here, you want to resolve this? They'd say, okay. And we ended up with significantly more money than that. But, you know, we're kind of the only ones, it feels like sometimes we're the only ones that are trying to go out here, and the amount of money we're working with compared to the size of the problem we're trying to solve, it's ridiculous. And it's partly a problem of our building industry being so disaggregated. You know, we have an internal paper that we really haven't released yet called My Car is Smarter Than Your Building. It's sort of like that bumper sticker, like my juvenile delinquent beat up your honor student. You know, it's sort of like that. And the reality is, my car is smarter than your building. I mean, and the reason is in largely because when car manufacturers, not that I'm in love with what they've done with energy efficiency, but compared to where they were, when they started to have to do cars that were both cleaner and more energy efficient, they looked at control systems, they looked at feedback systems. You drive a hybrid, I mean, you've got a lot of information in front of you. I get in my car, it tells me if I have low tire pressure. It tells me, I mean, they've got all this information, all this feedback going on. Those guys are aggregated. So, you know, 10 companies can make all these changes, and you get to the built environment and it's like, man, it's just all over the place. Thousands of firms, tens of thousands of designers, and, you know, owners all over the place, you know, some aggregation among owners. But there's nobody that cares enough sort of within the industry to put together a really decent research pile to answer these sorts of questions and move it along. I think it's one of our most compelling problems. And the energy, the utilities used to do a lot more of this. And then they were faced with the competitive forces of a decade or so ago, and they dropped a lot of their R&D budgets because they thought it would add to their kilowatt hour costs, and they haven't replenished those things since. And so there's just very little R&D money. One of the big moves that is being made is to put a lot more R&D money in the US budget. And in California, California is really the only state that has sort of state funding for research and development through the California Energy Commission and through the emerging technology programs at the utilities. I've been trying to get that model exported across the country with no success at this point in time. But we don't have any money that's going into these problems, basically. We just don't have an R&D budget that encompasses beyond a technology, that it's more systematic in terms of what it encompasses. So that's the heart of the problem. We're working with few resources.
I think we had one more question here, Jeff.
I think this goes to the same issue with when you had the Energy Star graph and all those lead buildings that were
Yeah.
down. I mean, how would you, nobody can characterize why those, I can't even call them aberrant, because I mean, there's a ton of them, so.
Well, I mean, again, we're trying to look at 10 of the worst ones, although not surprisingly, we had a little trouble getting volunteers for the 10 worst study. We had a lot more volunteers for the 10 best study. And again, I haven't looked at the data yet, but it appears that a lot of, as we were doing this, people were recommending buildings to us left and right, and it appears that we might have the 20 best and the 17 worst, I don't know. But we found some things that are just, some of them could be characterized as errors, like, one of them had a parking garage on the meter. We didn't know about it. You can have that sort of thing too. So it could be that these buildings aren't terrible buildings. It could be that they had a data center in there. It could be that, they had a restaurant, that they're a 4-story building with a giant takeout restaurant on the first floor, and it didn't pick up. So I'll know more next week, because we're trying to see if there's patterns here. And so we know we're going to find some things that are just errors, because anytime you look back, you find some mistakes of one sort or another. We're trying to see if there's patterns. And this is not a pattern of modeled versus unmodeled. This is a pattern of absolute energy use per square foot. And is that a reasonable barometer for how to measure the performance of your building? And why is your building so darn lousy when it was supposed to be pretty darn good? And we'll see if we come up with something. But, we ran into one building that we checked on, and they said, oh, well, that building's no longer occupied. We had so many problems with it. They said it wasn't any problem with green, it had nothing to do with green. It had everything to do with construction quality and finding somebody that could even build us a decent building. And in this case, we didn't have a decent building, and they ended up with such substantial problems that it's abandoned and there's a lawsuit pending. So, you have things happening in green buildings that just happen in regular buildings. And let me end on that final point, because it's, I spent a lot of time talking about these high performance buildings, but you see all this scatter in this data, and you see all these problems, and all I just wanted to say that this is not just a problem with these leading edge buildings. This is a problem with all buildings. Every building that we build has the same scatter of performance. And so, right now it's interesting, we're getting into some arguments with people who are picking on our study, saying this proves X, this proves Y, and it's like, well, sometimes it just proves that, LEED's just using the design parameters that we sort of use to measure whether people are building to code or not. So it's not a LEED problem, it's a code problem. And so how do you, if you actually want better performing buildings, what's your system that you put in place, and again, to get those buildings and make sure you're getting those buildings. And as you're moving towards a lower carbon world, that's why we have this now, 3.5 things we do. We have this measured performance thing, because I think we're going to have to go there ultimately, and that's going to change how we deal with codes. The Danes have an energy code that says you better well build a darn good building from a measured energy use perspective. Thank you very much for upholding our societal values here in Denmark. We could never get away with that in this country. People just build whatever schlock they wanted, but in Denmark, they tell people to build good buildings, and they get pretty good buildings. And we're going to have to figure out how to do some of that stuff here too. So, but some of these problems I'm focusing on are not just problems with the 1%. They're problems with the 99% as well, and we need to solve these things more broadly. So, thank you.
Very much. Coming this evening. Those here, I'd ask you to sign in. I don't think all of you got signed in. Please sign in. We need that information. And last of our series for the fall. We'll be meeting in January to come up with our spring series, and anyone wants to volunteer to help us do that, will give me an email, or if you have an idea, give me an email. I think most of you have it because I email you. Same with those out there on the web. So with that, thank you, and Dave, that was just great. That was wonderful. What a great.
And anybody who likes the Integrated Design Lab should have thanks for Dave, because he helped bring it here.
That's right. Exactly. That's it.